So last class we solved problem by plates. So when we solved both the cases, case number 1 when zigzag bolting and second case chain bolting. Now we solve same next type of problem when the angles are connected with gazetted plate. Here may be single angle or maybe double angle. So today video we solve single angle problem. So single angle problem, we will start with first problem where single angle is connected with gazetted plates. So this is the problem. I read the problem and we will continue with the solutions. A single unequal angle. So unequal angle they given 100 into 75 into 8 mm is connected to a 12 mm thick gazette plate at the ends with a 6 number of 20 mm dia bolts to transfer tension as shown in the figure. Determine the tensile strength of the angle if the gazetted is connected to the 10 mm leg. They are also okay. The yield strength and ultimate strength of the steel used are 250 MPa and 410 MPa. Okay, so the given diagram also. When you observe the diagram, it is an unequal angle 100 into 75 into 8 mm, and the given plan also where you can identify a number of bolts. They given 6 number of bolts connected with the pitch of 50 mm and edge distance is given 60 mm, and they given 40 into 60 mm, and this 60 mm nothing but you can say gauge. This gauge will get some cases is given, some cases is not given, means will get from the steel table that I tell you in the class. Okay, so now just observe here 100 mm leg is connected to the gazetted plate. It means that 100 mm leg is connected, 75 leg is outstanding leg because it is not connected with any legs. So now first you write down the given data. They given ISA 100 into 75 into 8 mm. They given 6 number of bolts 20 mm dia bolts they given. FU they given 410 and FY is given 250 Newton per mm square. Now here you can calculate the area. So area you can calculate directly from the steel table is given, or if don't use steel table you can calculate directly by using this formula. This formula is easy. They given 100 plus 75 minus 8. Why it is 8? So just understand here 100 mm is including 8 mm thickness. So that's why you make 100 minus 8 or you make 75 minus 8. Both the things are same. Okay, no problem. But 100 into 75 minus 8, or you can use directly from the steel table get same area, or you can calculate, or you can note down from the steel table as you according to your page numbers. Okay, so now here what happened, you have to calculate yielding of cross section, rupture of critical section and block shear. Okay, after calculating all this value, I have to check which value is this, that is your tensile strength of the member. So now here yielding of cross section, the formula will be same, TDG is equal to AG Fi into gamma m naught. So gamma m naught, how you calculate Fa also you know, Ag will get from the steel table or you can calculate from the formula. So now once you get TG, rupture of critical section, the formula for plate is different, for angles is different. For plate they given in page number 32, for angle they given in page number 33. When you refer page number 33 you will get the values. The formula will be different. The TDN is given 0.9 into FU into ANC divided by gamma m naught, gamma m1 plus beta AGO Fi divided by gamma m naught. So this is the formula, and they given beta. Beta also is unknown. Beta also given in the still IS code book. This is page number 33. So beta formula is given. Now here you have to calculate first thing what is W. So W is nothing but this formula also given page number 33. Please check. Okay, so W is what happened, 100 is connected late and 75 is outstanding late, that is we say W. So T, you already know thickness is given 8 mm of the angle. Okay, so BS is equal to 75 plus 60 minus 75 plus 60 minus 8 divided by this, which is 60. 60 is nothing but gauge, that is already given the diagram. This is 60, this is given the diagram, this is 60, or you can note down directly from the code book. So from steel table you get. So how you get the steel table, I'll just show you. So in the steel table, when you're referring IS, in this table they given here revealed gauge distance in leg for angles. So when you see the diagram here, they given two values A and B, that is for two bolts. For single roll of rivet or bolts, they given here value. So when you observe here, 100 mm is the leg. Okay, if it is two bolted, 40 into 60, 40 they given. If it is only single bolt, the G value is given as 60. This table you have to refer. According to my steel table, the page number is 168. It may be differ from your steel table. So now come to the point here. Next, once you get 75, how you get 68, we already explained. So minus 8 is you get the 127, and this formula is given in the code book, page number 33. Now list LC. LC means what happened? Length between the holes. So now when you observe the diagram, how many bolts are there? Number of bolts is 6. So number of gap will be 5. 5 into what is the pitch? They given 50. So that's why you taken here 5 into 50 will get 250 is LC. So ANC. What is the ANC? ANC is the area of connected leg. Net area of connected leg. So it is given as 100. 100 is the leg. 8 divided by 2, because this is thickness divided by 2, you will get exactly the center. Minus 22 is the dia of the hole into 8. So you will get 592 mm. So similarly you have to calculate for outstanding leg AGU, that is 75 minus 8 by 2, because there is no connected any bolts. So that's why you take only 8 by 2 into thickness. So you will get the value ANC AG. Similarly you have to calculate beta. So when you substitute all the value, you get 1.179. Now you can calculate TDN. TDN we already know, the formula is given above. So that formula you get the value of TDN. So now you got two values, one is TDG and TDN. Now you have to calculate block shear. When you calculate block shear, you have to know this diagram. Now you already explained this, because last classes we also solved this problem. I already explained the video. Just see the video. Same thing, VG. Again I repeat this, AVG. Totally is what happened, 50 into 50 into 550s. 250 plus edge distance is 280. 280 into thickness is 8 mm. So now in this area, how many we have to calculate net area after detecting holes. So hole we have six number of holes, but we will consider only this 5 plus half. Last bolt is hole is only half. So 5.5 into the hole size is 22 into thickness, will get this 80G. So 40 into 8. What is the 40 into 8 here? 40 into 8. Okay. Now finally you will get, last one is 40 minus 0.5 into 22. So we'll get this is actually wrong. So this is actually should be 50 into 8, and the next one is 50 minus 0.4, because pitch is given here 50 mm. Okay, so this make changes 50 into 8. Okay, so pitch is given 50. This is pitch and T, and this pitch detected with the holes. So after getting all this, you can see here you can calculate TDB and TDB2. So all this value you have to compare now. Whichever value is less, that is your desired tensile strength of the angle section.